Today we'll discuss about the syllabus pertaining to control systems of R23 regulation during the academic year 24-25. So I'm P. Naveen, working as assistant professor in the Department of Triple Professional Institute of Technology. So I'm handling control systems during this academic year. So for this, so this is the core structure of R23 regulation, second year, second semester. So during which we have a control system subject, and for which every week we'll have 3 lectures. So that will get you 3 credits for the subject of control systems. Coming to the syllabus of control systems, so the syllabus is quietly divided into 5 units. So unit 1 has got mathematical modeling of control systems. And in this, first we'll discuss about the classification of control systems. There are, as I said, there are 11 to 12 classifications of control systems, among out of which we have got the best classification as open loop and closed loop control systems. And there, we need to discuss about the differences and advantages and disadvantages of open loop and closed loop control systems. After that, we need to discuss about the feedback characteristics. Then we need to define what is transfer function, what is the importance of transfer function, what are the drawbacks of limitations of transfer function. Then differential equations of electrical networks, that we must have the basics of writing differential equations, which must have done in electrical circuit analysis. Thereafter, we need to discuss about translation and rotational mechanical systems. Next, transfer function of armature voltage controlled DC servo motor. There is also field control, but in this syllabus we got only armature controlled DC servo motor. And we need to discuss about block diagram algebra and representation of the same by using signal flow graph and the methodology to find out the transfer function or the gain of the system by using Masson's gain formula. So that covers the unit 1. Coming to unit 2, that's time response analysis. First, we need to discuss about various types of signals that are to be used in testing a system. Next, we need to find out, we need to know what is order of a system, what is type of a system. Then we can understand what is time response of a system corresponding to first order and second order system. That is limited to only second order system. You don't go for third or fourth or fifth order systems for time response analysis. And we need to know about time domain specifications for second order, specifically for second order system. We need to know about rise time, peak time, settling time, maximum peak overshoot, steady state error. Okay. And apart from that, we need to know about error coefficients and error constants. Next, you need to know about effect of proportional integral and proportional integral and derivative, all these over the control system. In the same unit, we have got other part, that is stability and root locus technique. And the stability, that is qualitative stability is defined by this Raut-Hurwitz criteria, where we'll be getting the idea of having only a system to be a stable, unstable, or marginally stable. And we will not know the quantity of stability. Okay, so that's the idea of having Raut-Hurwitz criteria. Next, we need to know about the limitations of Raut-Hurwitz criteria. Next, root locus concept, construction of root locus or loci, effect of addition of poles and zeros to the transfer function. Next, coming to the third unit, frequency response analysis. As I was saying, quantitative study of stability can be done by frequency response analysis. So we need to know what is frequency response, what are the frequency domain specifications as done in the time domain specifications. So we need to know about board plot, board diagram, how to draw a board plot, board diagram. Next, we know about Chloral plot, Nyquist plot, stability analysis using board plot. Next, coming to the fourth unit, the classification of control design techniques. We have got lag compensator, lead compensator, lag lead compensator. We need to realize these compensators, the transfer function, and then you need to design the compensators for various uncompensated systems by using border plot. There's also root locus technique, but still we are in this syllabus, we have got only board plot technique of designing the compensator for uncompensated system. Next, coming to unit 5, we've got state space analysis of LTA system. The concept of state and state variable, what is state variable, and state model. So state space representation, we have got two equations. One is state equation, the other one is output equation. We need to derive those two equations for any system. It may be electrical system, or any differential equation, we need to derive it. We've got methodologies like controllable canonical form, you've got observable canonical form, diagonal canonical form. Okay, so in these three methods, you need to derive the statement. And you need to know about diagonalization using linear transformation. Next, solving the time invariant state equations. So state equations are of two types, time variant and time invariant. So time invariant system, how to solve these two equations. Okay. Next, we need to know about state transition matrix and its properties, very important, and concept of controllability and observability. So this entirely covers the entire syllabus of 5 units, which is sufficient for a BTech level of understanding. Okay. So thank you, and we'll meet again.